So today we are talking about fault injection or requirements testing for ISO26262. I'm your host, Winfried Schröder. I'm working as Business Development Manager at Vector Software, and I will moderate this webinar today. Our presenters today are Martin Heininger, General Manager at Heicon Global Engineering. Hello Martin.
Hello Winnie.
Our other presenter today is Michal Jablonski, Field Application Engineer here at Vector Software. Hello Michal.
Good morning everyone. Hello Winnie.
So our agenda for today, I'm going to start with a little overview about Vector Software and our solutions. Martin will then give his presentation about the question fault injection or requirements-based testing for ISO26262, which will take up most of our time today. Michal will give us a demo of Vectorcast. Please chat us your questions so that we can answer all the questions at the QA session at the end of this webinar. A little bit about Vector Software. Vector Software offers embedded software testing solutions and services for safety-critical applications for regulated and non-regulated industries. It was founded in 1990. The first version of Vectorcast, our unit test solution, was released back in 1994. We are headquartered in Rhode Island at the east coast of the USA, and we have sales and support worldwide. All the presenters of today's webinar are located in Germany. A short overview of our customer base. We have customers in all industries, nearly all over the world. Historically, these companies develop software for safety-critical applications, but today we have many customers without any certification needs, but which want to improve the software quality. Vector Software started in aerospace, avionics and defense, but today we have well-known customers in automotive, industrial automation and medical industries. At a high level, Vectorcast impacts your business with three things. First, it improves the software quality, it reduces the time to market with faster test results, and it lowers the lifecycle cost because less errors gets in the field. Therefore, the cost of maintenance, redesign and reuse in your development team are lowered. Some of our key technologies are unit and integration test automation, code coverage, continuous integration with change-based testing, agile, test-driven development support, and of course embedded target support. The way we are looking at software development and software test in particular as an evolutionary approach. Some organizations are doing nothing or very little. Everybody is doing some kind of system testing and probably checks code coverage to see where they are with their testing. We at Vector Software help organizations to get started on the left and move forward to the right side and optimize the quality of the software. And with that, I would like to turn over to Martin Heininger and his presentation.
Thank you very much, Winnie. I take over the presentation now. Hope everybody can see now my screen. Welcome to this presentation about fault injection or requirements-based testing requirements-based testing or whatever. That's what we are talking about today. According to the ISO26262, so automotive industry, as this fault injection topic is mentioned in the ISO26262. The rough content about the presentation is here. First of all, the definition of both statements, fault injection, requirements-based testing. Then we will have a quick look in the aerospace industry, so it's a different industry, how they are doing in this area. Conclusion, still then about 26262, why is it there like it's written there? Yeah, there are good reasons. And finally, contact and my publications. And before we start, very short overview about my background. I studied electrical engineering until 1998 in Augsburg, so in South Germany. Then I joined a testing company in Ulm. I went on in 2004 and 5 to aerospace industry, a big aerospace supplier, tier 1 deal in Überlingen. And since 2005 I have my own business with Heicon. I'm doing, as you can see on the right side, consulting, coaching, seminars, and here this webinar in all these areas. As you can see, functional safety is the main topic. Intercultural management to India is another big topic, and testing is where I'm coming from. Okay, then let us start in the presentation. Fault injection testing. I think a lot of you have heard about the topic, and if you have ever dealt with the 26262, you have probably experienced that you should do it, and you will be asked in audits, and your customer will ask you, have you done fault injection testing? And I want to, first of all, before we go deeper in the topic, see what does the 26262 state about it. First of all, there are two statements there. First statement is on system level, so fault injection on system level. As you can see, it is stated the test uses special means to introduce faults into the item. This can be done within the item, special test interfaces or specially prepared elements or communication devices. And now three very important points are coming. The method is often used to improve the test coverage of the safety requirements, improve the test coverage of safety requirements, because during normal operation safety mechanisms are not invoked. We will come back later on this statement, as I'm talking today about the method and not so much about the implications on test environment and all this stuff, like what is more mentioned in the first part of the sentence. Yeah, test uses special means to reduce faults. I'm interested from a methodological point of view, and therefore these statements in the standard are very important. The same here for software, on software level. Fault injection, also in the 26262 is written on software level, fault injection test includes injection of arbitrary faults in order to test safety mechanisms. For example, corrupting software or hardware components, corrupting values of variables by introducing code mutations, or by corrupting values of CPU registers. So I want to highlight a little bit, as you can see, these arbitrary faults, because I believe these statements, these green underlined statements, are a root cause of a lot of discussions, or the root cause of a lot of discussions and maybe uncertainties what to do and how to deal with this topic. There are in the 26262 in part 4, 5 and 6, so system, hardware and software, there are several times the fault injection is mentioned. You can see in the tables in system level it's 2, 4, in 6 tables it's mentioned fault injection testing. Even on hardware level we have fault injection, on software level also 2 times. Fault injection is somehow a topic from system point of view. As you can see, the main focus is on system. I think there is no doubt. However, even on unit testing, you can do fault injection. It's a question of how you interpret, how you define it. For all the people who have maybe not seen so often the 26262, there are these tables which I'm just talked about, and here we have now the table 10. You can see in the system part, so part 4. There is mentioned for system integration and testing, which covers here the topic verification of functional safety and technical safety requirements at system level. There is given, yes, you should do a requirements-based testing. When you can see here the different ISO levels, of course, the methods you choose are depending on the ISO level you have to follow, which is previously defined by risk and hazard analysis. So you can see in all 4 levels you need, it's highly recommended to do requirements-based testing. as the whole topic is about functional safety and technical safety requirements, it's no wonder, I would say. But also here it's stated fault injection testing, and for ASIL A it's recommended, plus means recommended, plus means highly recommended. ASIL B, C and D recommends, highly recommends also additional to the requirements-based test, the fault injection test. Not so much in focus of this presentation here is the back-to-back testing. I want to highlight these two topics, yeah, requirements and fault injection. So another table, why can't I switch now? So, sorry, it's working again. Fault injection testing on system level in another part, yeah, is system integration and testing, the effectiveness of safety mechanisms and failure coverage. Failure coverage at the system level. Also here it's called fault injection. Here also the fault injection testing is called, and actually the requirements-based testing is not called. Yeah, that's what I find interesting, or what I want to highlight today. Again, error guessing tests and tests derived from field experience is not in the focus here. So let us have a look for requirements-based testing. How is this defined? Requirements-based testing on system level, the 26262 says a requirements-based test denotes a test against functional and non-functional requirements. Not of a big surprise, I would say. Yeah, functional requirements, what is the difference to the non-functional requirements? But I think roughly we can understand what is meant. We have a requirement, we're going to verify it. On software level, the 26262 says a software requirements at a unit or architecture level are the basis for requirements-based test. And as we go later on in a different industry, I would like to highlight here this topic, architectural level. A software requirement at the unit or architectural level. There is this word architecture is there, and from my experience in the automotive industry, there is not always a real requirement in textual form. Sometimes it's really the architecture or design you're testing against when you're doing unit testing. The statement here is, from my point of view, can be interpreted in different ways, and in the practical way it is. So on system level, on software level, you see requirements-based testing. There are, it's in each level there are 3 tables. Not actually on system level it's 3 tables. On software level it's 2 tables where it's mentioned. But we have now a rough understanding on what is requirements-based testing about, or what this 26262 especially means about it. Examples here are the software unit testing. Here you see as one method requirements-based testing, highly recommended for all ISO level. Interface testing, not so much in focus, and even on software unit level, it's additional to the requirements-based testing, one method called fault injection testing mentioned, yeah, which is, let's say here, only recommended. Requirement-based testing is highly recommended. In the integration, software integration testing, there you have again requirements-based testing and fault injection testing. The difference is here ASIL-C, where you have highly recommended. You have been recommended in the unit testing before. So for ASIL-C and ASIL-D, you should do kind of both, yeah, requirements-based testing and fault injection testing. Okay, so as a conclusion for the automotive industry, what do we have there? Requirements-based tests and fault injection tests are treated as 2 different test methods. Yeah, as you can see, you have it mentioned in the standard as different methods. You can choose sometimes you should use both. Second, the ISO26262 assumes that these tests are required to increase the test coverage of the safety requirements. You remember this statement that in the system level the fault injection testing is often used to increase the test coverage. So let's assume from what I assume is that the 26262 assumes that you don't get a full coverage with requirements. Yeah. Therefore, you increases with the fault injection testing. Next statement, with the fault injection test, arbitrary faults are injected into the system to prove that the implemented safety mechanisms are working. Question will be again, we want to focus on what does we mean with the arbitrary faults, or how do we look on the arbitrary failing or failures? Of course, as we introduce failures, there should be in the system, as it's a proper safety system, mechanisms implemented which then will show that they are properly working. These are the three conclusions I take, the three important ones I want to focus today in this webinar. Now I would like to have a look in the aerospace industry. As you have seen, my background, at least until 5 years back, it's mainly aerospace, and the last 5 years I did a lot of different industries, but I have a strong background in aerospace, a lot of certifications done there, and therefore I want to compare this with how the aerospace industry deals with this fault injection testing. So let's have a look there. In the aerospace industry, we have different standards, of course. Yeah, what is ISO26262 as one standard in automotive? It's roughly 3 in the aerospace. DO178C, it's the software. DO254, it's the hardware. And last but not least, also aerospace has lately 4754, 4761, so on system level a standard. So they are, from my point of view, comparable. It's about software system development processes, how have they be considered, what have to be done, what have to be implemented. Let's have a look in the standards, let's go through it, and let's search for the expression fault injection testing. Yes means, do I find it? And I have to conclude, no, I don't find it. It's not there. It's not in none of these standards you find the statement fault injection testing. I think all of us agree with experience that in general fault injection testing is very important. There's no doubt about that. But interesting question is now, why is it not mentioned in the aerospace? Yeah? What is the reason? No, so we don't find this statement, the fault injection testing. What is about, the next one we are going to search for requirements-based testing. Will we find requirements-based testing? No, means it's not allowed. We need to do requirements-based testing. It's very, very strongly recommended, or it's not enough even strongly recommended. You have to do requirements-based testing in aerospace, very, very heavily. There's no chance of certifying any safety critical system without having done requirements-based testing. It's mentioned in the standards and the norms. We have, even aerospace has, even in the software on the 178C, explicitly 2 levels of requirements mentioned, high-level requirements and low-level requirements. So and this results in the industry that you have no freedom, from my point of view, on low level. Even on low level you have textual requirements. This is comparable to the unit level, unit architecture level in automotive industry, where I said before there is, from my point of view, a bit of freedom. At least the industry is not that strong so far. In the aerospace it's very, very strong. Even on the unit level it has to be textual requirements. It's not mainly not requirements which are represent architecture or design. I know with model-based development it's a bit changing. Yeah, we have scenarios where we don't have textual requirements, but still we have a strong emphasis on to show what is our low-level requirement in the aerospace. So don't want to go further there. Just for people to say, yeah, it is possible to have non-textual requirement. This is true. However, even so, even if this is used, there's a lot of work to be done to show what are the low-level requirements. So let's say, yes, we have the requirements-based testing, but no fault injection testing. What else do we have in the 1780. Or let's say if we find requirements-based testing, there is something missing from my point of view, yeah, because fault injection testing is important. So we will find two statements there, or two terms, which are very, very important, and they are called normal range test cases and robustness test cases. So I would say I want to compare and say, okay, these are the two statements or terms I get in the aerospace. I have to do normal range tests and I have to do robustness test cases. I don't find fault injection testing. So somehow I believe now, it's this assumption, that normal range test cases and robustness test cases will or have to cover the fault injection testing. Let's see. Let's see what is about normal range tested. If you go there in details in the aerospace standards, we would not, if you do not do normal range tests, then we are just no chance. Yeah, we have to do. No, it's not allowed. Yes, then this is not sufficient. If you have ever experienced aerospace, if you come up with some nice testing and you can't show that you have done robustness testing, you will fail for certification. So robustness testing, no, it's the same, not allowed. You have to show that you have done robustness testing properly, and moreover, you have to show 100% code coverage by requirements. I'm not talking about the structural coverage now, I'm talking about 100% functional coverage, if you like, by requirements. The latest aerospace standards, 178C, makes it even more clear than it has been so far. There is no, in future there will be no test be allowed without having any requirements against. However, the robustness testing is still, even in future, will stay a bit outside of that, or on the border on that. Yeah, the philosophy is you have a requirement and you go to verify it, and the requirement somehow defines borders of your system, behavior until, don't know, a certain value, the system is working properly. Above a certain speed, for example, the system is switching off. Maybe, yeah, this may be a requirement, so you're going to verify inside, below 50 kilometers an hour, a system is doing what it's supposed to do. Outside 50 kilometers an hour, it's switching off, let's assume that. What is if you're going to test this 50 kilometers an hour, you take 60 or 70 kilometers an hour, we're testing its system is properly switching off. Is this now a robustness or is this a requirements case? Is this a normal range test case? Is this a robustness test case? That's a bit the difficulty. However, if you, I would say it's requirements-based testing actually, yeah, because there's a requirement and you're going to verify that it's switching off above 50 kilometers an hour. However, there are still scenarios you will, in every system you will find scenarios which are not really verified or defined by requirements, and that's the idea of robustness testing. You're going to search for holes in the requirements, kind of, yeah, and then you go to define new requirements if really necessary, and this is then an engineering judgment, of course, and so you end up in the end with a close or closer to, as now, 100% code coverage by requirements. So not allowed. So if we do so, then the behavior in all failure cases is defined by requirements. The 50 kilometers an hour or 60, 70 kilometers an hour, if this is a failure case, then system shall switch off. Yeah, this is a requirement. And if you have 100% requirements coverage of your source code, then each and everything which is implemented there is covered by a requirement, so each and every failure case is covered by a requirement. And the system on a system behaves according to the requirements. All the failure cases are deterministic as long as you have a deterministic system. So it's difficult, or is there a need to define a fault injection testing, yeah, as you have everything covered by a requirement, and the requirement has another advantage. You have an expected behavior defined, yeah. 60 kilometers an hour, system shall switch off. There's no undefined, it's clearly defined. And that's the big, strong advantage, and that's the big and strong advantage again, and therefore there is no need to define define another test methods. Actually, there is requirements-based testing with normal and robustness testing, where you go to test the edges of the requirements and above it, and re-question the requirements. If you do so, then everything is covered. So this slide is now a repetition of what I just said. I think robustness testing behavior in any case of any failure, is essential part of testing. Requirements will be put into question through robustness cases, just said. In a lot of cases, pass-fail cannot be defined as expected test results, as we have not a requirement probably for it. We found holes, yeah. So we have to discuss, and for some cases we're not even going to define requirements. But important is to discuss this and to decide it and to make the decision visible actually also. Robustness test results have been discussed with system specialists. Yeah, that's what I meant. So result is then definition of new requirements or change of existing requirements. So if you do so, the fault injection testing gets a part of sometimes normal range tests or part of the robustness testing. Yeah. In one of these two categories, any fault injection test has to be there. Fault injection tests are finally always based on requirements, as if you follow the Aerospace, yeah, because nothing is there without a requirement. There is no need to define a separate test category fault injection test because of these first 2 points. So let's say a bit of a different philosophy, I would say, yeah, in the Aerospace. Not saying wrong and right, I would just say a bit of a different one. Conclusion. So if you take now this knowledge from aerospace industry with us, and we look again on the definition in the 26262, that the method on system level, the fault injection method, is used to improve the test coverage of the safety mechanisms. What does this mean? Fault injection testing is a very, very effective, if it is possible, to define expected test result. Yeah, I think it's right. Actually, you can improve your test coverage. This is in the aerospace your robustness testing, where you find new requirements. So somehow you can compare this here. But you need to define then the result, or you should. Otherwise, the tester in the test laboratory decides about correct or not correct, and that's what I feel is wrong, and it is above the decision of a tester. You should document that, yeah. And if you document the expected behavior, then your fault injection tests are very, very effective and very, very strong. Yeah. An expected result can only be defined if requirements are available. Yeah. I don't know how else you would like to do it. Yeah. The requirement is what the tester is testing against, and that's what you should think of far before the tester comes into the picture. Yeah. It should be when you define your system behavior. Especially all the failure cases which have impact on customer. The customer can see it. The failure, then a system team, system designer, system architect, safety architect should think of and define the expected behavior. So the tester can prove, yes, it's behaving like that, or no, it's not behaving like that. That would be the role of a tester, or should be the role of a tester. So in this case, if we have this, then we have all the requirements, and then I'm getting in trouble. That's, may you see where I'm coming from, yeah. When with the whole presentation, I'm coming from saying, wait a minute, why do we need fault injection testing? Everything should be defined in requirements. So if so, then still I would say it's a subclass. The fault injection testing is a subclass of requirements-based testing. No doubt about that. I would never throw it away, but it's then just a subclass anymore. So what is about these arbitrary faults? Fault injection test includes arbitrary faults on software level in the 26262. And you still see the examples there: corrupting software, hardware components, corrupted hardware components. So these are arbitrary failure on the hardware, can be, for example, yeah. Still, your system, your safety architecture should ensure that your arbitrary faults, also your arbitrary hardware faults, if we're talking about them, are resulting in defined system behavior. That's exactly the task of a risk and hazard analysis, yeah, from my point of view, including FMEA, FTA, and so on and so forth. So therefore, whatever failure occurs, you should be able to define a result. We all know that there are boundaries on that it's difficult to do it for each and everything, but at least we should try. And if we try it, when we see in the aerospace, we see that we come quite far. We get it quite close, closely solved the problem. There's not many issues open. So as long as it's of course a deterministic behavior. In this presentation here, in this statement, we are not talking about new things in called other system where we have intelligent system which self-learning systems and so on and so forth. If we have such system, we will get, from my point of view, a different functional safety setup. This is outside of this presentation. So we have a deterministic system, so we know how it's behaving. Arbitrary faults does mean, in this context, a failure out of a known list of failure. That's what I would call arbitrary faults. So therefore I can test, yeah, I should be able to test. I should be able to define without the testing the expected behavior because I have requirements, yeah. So I have a list of my failures, yeah, and therefore I expect or I define how the system shall behave. And if I define arbitrary in this way, then I'm fine. And yeah, from my point of view, there are not much more interpretation senseful from, I would say, yeah. This is what makes sense to be done. Fault injection test classes are very important subclasses of requirements, so I would not say throw it away and forget it. Yeah, it is very, very important. Why is it very, very important? Because it forces or it requires good requirements. It's not easy to write requirements, especially in early cases, in early stages of the project. You're thinking about what the customer is buying. You know, the customer discusses with you what he's buying, and you're not thinking about the failure cases and the behavior of the failure cases. The customer very often don't care even. He buys a working system, not a system which is failing from you. So there's a lot of effort to be spent in the requirement engineering. Yeah? It's your knowledge, it's the knowledge of the customer. It's a difficult process. So, but it should be, if we have something like fault injection testing in the background, we hopefully remember ourselves when we're doing requirement engineering that we have to think about the behavior. Then we have special thoughts or special needs for the tester itself. Yeah, if you're going to test failure cases, you have to be very motivated, very you have to be creative, yeah, to know where to start and where to stop. Of course, almost every technical system can be brought in a situation where it's just out of any senseful, any defined behavior. Let's do it this way, any defined behavior, and we are outside of the use case and even out of the foreseeable misuse and things like that. Yeah, so the tester, if he is too destructive, the system will never be passed. Yeah, it will always have some failures. So that's what I mean with selected testers proper order. We need special thoughts about this, and of course the test environment, so the technical side of it. Yeah, test environment has to be better than give more possibilities than the system itself. So you have to be faster maybe because you want to introduce every 10 milliseconds and failure. Yeah, system is working every 100 milliseconds, things like that. So very, very fast. Other things, you bring always the test environments to their edge if you think about failure injection testing. So therefore it's very important to think about that. Yeah, to think about your requirements which have failure injections in the background, which are talking about fault injection testing in the end, more or less. So finally, to come to a conclusion of this presentation, why is the 26262 still right? Yeah, may have talked about, criticized now, let's say, how somehow the 26262. Why do I believe, or why do I think it's still correct what it's there, and how should we consider it? So again, the comparison between these two industries I did before. From my point of view, requirements engineering in the automotive industry is as I experienced in the last years, it is pretty new, or it is new. Even if you say the tools like doors and even requirements engineering is there for years or decades of years, but really in this intensive way as we have to do it now, I believe in the automotive industry, or my experiences, it's pretty new. A lot of experience is missing. The aerospace industry has a lot of experience, 30 years, because there are authorities where you have standards there since 20 years. Industry is small actually, therefore you have a common understanding throughout the whole industry, a common interpretation about the words in the standard, which is in the automotive industry also not there. It's a big industry, and it's not everybody has the same understanding of the standard. Another argument, despite of an ISO level, the project do not have the experience to detect the right quantity and amount of details in the requirements. Yeah, this is more or less a consequence of the first topic. Yeah, and actually in the aerospace industry, the quantity of requirements is in many projects too high. They're writing too many requirements. Actually, I've seen this also in the automotive industry. Therefore, I wrote detect the right quantity. Sometimes it's much too much, but sometimes it's also too less. Both is possible. Both you can see. Both is not good. Both is bad. Both cost a lot of money. Another one, fault injection tests can help to validate the safety mechanism in early project phases. In the automotive industry, there's no doubt. And my argumentation, that I just want to tell you this, but the aerospace industry was heavily driven now by certifications. So in the argumentation, it's mainly based on the proof of correctness of the process towards the authorities. Yeah, early phases of the projects are not in the focus in the sense of certification. However, somebody else who have heard this presentation told me that, yeah, but the 26262 is also not written for early project phases. Yeah, it's not for a prototype, it's written for the final series. However, this is a positive point from my point of view for the automotive industry. You should, and even the standard writes it from my point of view, you should look even in early phases. You can prove your safety mechanisms, yeah, without any certification or process stuff. Yeah, please do it, because if you are early right with your system, you will save a lot of money. So, final conclusion, less experience, or put it together in one sentence, less experience in the requirements engineering and the importance of the fault injection test to fulfill the safety aspects are very good reasons to define fault injection tests as a separate test category in the 26262. I believe, as I follow up the discussion in the automotive industry, that even in the new 26262, the fault injection testing will stay there. I hope that it's getting a bit more clarity, that people who are new or not so experienced get a bit better guidance, because that's what I feel at the moment with these many test methods which are there. Do not forget error guessing and back-to-back testing and requirements and fault injection and so on. A lot of people are pretty confused about what to do now. Yeah, it's difficult to write one test. I should use now different test categories and methods. It's too much for a lot of people. Yeah. So I hope that we get a bit better guidance. Still, I think it will stay. So, last but not least, thank you very much from my side. We will continue now with the Vectorcast presentation, where we can see even on source code level fault injections, yeah, how you do fault injection on source code level and how Vectorcast can help you there. And it's also covering one aspect. You can see here my contact details and my publications. Do not forget my blog articles every month to have maybe a look there on the blog heiconulm.com. I'm happy to see you there, and you can give a comment there as well. So thank you very much. It's now on Michael to continue.
Thank you, Martin. Okay, probably you all see now Vectorcast all it is showing.
Yes.
I will present you a how can we inject faults into source code during test cases. But before I will do it, let me answer a question, or rather talk about the problem. How can we stimulate our function? So how can we stimulate the function the test? And the answer will be also the answer how can we inject faults into source code. So basically there are three major ways how can we stimulate our source code. That means that we can pass some data through, for example, parameters. That would be the first way. Another way would be using global values. The function would read it or maybe write there and behave depending on the value of the global variable. And the last way how can we stimulate our function the test are the functions that are called from our function. And that means that probably the function called will return something, and upon the value that we receive from the function, we can behave in different ways. So I prepared here a small presentation, a small source code. Let me enlarge this. You see it has example function 1, and it has 4 really parts of source code, and you see every part is one if condition. And really what is happening here, we're checking all those three different stimulants. So in the first case, we're checking a temperature, which is a global value. In second part, we are checking the value of the parameter, and then the fourth and the first and the fourth condition is running some function, calls some functions, and behaves upon the value that we receive from those functions. Why we have here 2 functions instead of 1? So the thing about Vectorcast is that we would stub or mock automatically everything that is outside the translation unit or the file that we are testing. Saying this, the getSpeed function is outside our translation unit and will be defaultly stubbed by Vectorcast. So the whole pain of writing stubs and mocks is gone from a developer or a tester. And then finally, the fourth if calls a local function, a function that is defined just here above my example functions, are in the same translation unit. And as I said, we defaultly stub everything outside the translation unit, but it doesn't mean that we can't stub it. Vectorcast is pretty flexible here, and we can create a stub out of this and inject some faults, which I will show in a minute. So let's try to run the first test case I have here. You see I'm just passing here a neutral gear value, and my expected value is 0. So if the function behaves correctly, it will return 0, otherwise we'll get 1. So if I run now this test case, you see I got my execution report, I've got it green, and I can see my my coverage of the test. You see I've got 3 different colors. Green states for fully covered. We've got some orange-ish. You see the T letter means that I tested the true branch, but I never tested the false. And you see all my 4 my 4 conditions were tested only with true. And then finally I've got red. So all the problems, all the error conditions are not tested at all. So if I start with my temperature part, you see here in the test case my temperature is under the global values. So I can set here any special value. I can put minimum, maximum value, but I'm using here NaN, standing for not a number, clearly a fault, clearly an error value. So let's see what happens. Okay, I've got green. I received 1, which stands for an error. Now if I click back to my coverage, you see that now this error condition is covered. Second fault induction, as I said, we can do it through a parameter, through an interface. So my gear value here is an enum. It has 4 different levels: neutral, reverse, parking and drive. So I'm putting some totally insane value of 999, which is totally outside my enum range. Let me run it. Great, and you see this part is also tested. In terms of get speed function, we need to get speed over 240 kilometers per hour. Of course, in a normal situation, something like this is impossible in most of the cases, probably, to achieve. But here we can. You see, I'm stubbing my get speed function, and I'm returning the maximum value of my long type. So if I execute this, you see here that my max stack, my special value, was changed to 2,147,000,000, etc. And finally, my last test case, where I'm using the local functions. As I said, we are not stubbing this by default, but all I had to do is to just check this box and inform Vectorcast that I would like to use the stub version of this function instead of the concrete one. You see, I'm returning here 300, execute, awesome, everything is green. If I go back to my coverage, everything is green. So I got 100% coverage and injected some false. So I've got also a second example here, which could be a bit more maybe interesting, but before I show it, I can tell you something about the requirements. So if I tested all my my functionality, I tested my function, I can go now to my requirement gateway and connect to my requirement tool. Here I've got a connection with Polarion, but I could also connect with DOS or Excel and import my my requirements. Now what I can do with my requirements, I can link them with different test cases. So I can say that, hey, my global variable here, test case for injection was, let me move it here, was testing this requirement. I can save this now, and I can export this information back to my requirements tool. So my name of the test case, pass-fail information, the coverage would be exported back to my requirement tool. So now, example number 2. Let me open source code. And you see, as I said, it could be a bit more interesting because you see here, I'm accessing a hardware registry, and I'm setting a value of this to 1, and then I'm checking whether it was really set to 1. So maybe this could be some sort of soft error. Alpha radiation could prevent or rather change the value after setting it. And then I've got here, you see some structure. So to understand what this really HW address and the structure, I need to jump now to my header file, which is, I need to click on this, open Halden. So you see my HW address is just defined, and it's defined as accessing a certain memory area, whereas my WDT structure is defined as a memory location, hard-coded memory location, and then it's casted to some structure. So how can we test this, and how can we inject some faults here, especially if you think about the first case when I'm setting the hardware or memories into memory area into 1, and then I'm reading this and I'm checking whether it's really 1 or not. So first I will need to have a hardware, of course, because I'm using here hardware, but in many cases we don't have access to hardware, and in many cases we'd like to run the test cases on a host machine, as I'm doing right now. And the second, getting into this if software set 1, so when this is not true, is pretty difficult to simulate on the hardware, if even possible. But in Vectorcast you can extend the test harness on with a user code, so a concrete C++ code. So if I go to my user code and I open here the unit appendix user code, you see what I'm doing here. Let me just make it more readable. I'm undefining my HW address, and I'm defining it again as a function, any function really, that I will use, and I will stop, and I will tell the function to do whatever I want it to do. And then I'm doing also the same with the structure WDT. I'm undefining this and defining this again as a function, which again I will stub to use it and inject some faults. So my first test case, all good. So you see, I'm using those two functions that I just defined in my user code, and I'm passing all the good values. So I'm setting just once to all the fields of the structure, and I'm stubbing my address stub or HW address to return always 1. So if I run my test case now, and you see everything is green, I've got 0 as a match, and in the coverage, here you see I tested the happy path. So everything worked as it's supposed to be. The thing that you can maybe spot it now, my HW address is not anymore here. It was changed to my stop address. The thing is that we pre-process the code and we pre-process all the defines. Of course, if you jump back to your source code, it's still going to be HW address. But if we talk here about the coverage report, it's going to be used the one from preprocess. So now let's try to jump to the first false injection test case, F1 address access. So you see here, instead of returning 1, as I did in the first example, I'm just returning some bizarre random value of 1 to 3. So let me run the test case. Okay, you see that my fault injection worked. I jumped into the soft error branch part, and then I'm still missing, to get 100% coverage, the last branch here. It's red, so my WDT memory shouldn't equal to 1. And you see here in my stub structure, I'm just returning 0 instead of 1. And after running this, you see I got 100% coverage. Let's go back to my coverage view. Everything is green. Awesome. So thank you. That was my technical demo on showing you how you can use Vectorcast and testing for getting fault injection and connecting this with the requirements tools. I'm giving voice back to Martin, and we will jump probably now directly to Q&A session.
Yes, thank you.
Yeah,
we will start the Q&A session. I will switch the monitor to me. Martin, do you have already questions to answer?
Yes, there are several questions about it, about the statement. First question, do you use any, a very interesting question from my point of view, do you use any requirements pattern when writing fault injection requirements? And I could say yes, you can use patterns like if failure such and such occurs, the system shall behave like such and such, yeah. You could use such patterns, but this isn't, of course, will first of all not define all your fault injection cases or all your failure cases, because you will have other requirements which you can't write in this statement, and they're still covering failure cases. Secondly, you have to start at the risk and hazard analysis. Yeah, there was another comment then about, yeah, these requirements are maybe then still poor, or how can we be sure that we have covered each and every case, each and every failure case? Maybe by fault injection testing. Yeah, that's the end at the testing end. Yeah, but if you start on the hazardous and risk analysis side, assisted by FMEA, FDA, FTA, then you do an analysis, and out of this analysis, then you get requirements. You get a bunch of requirements which define most of your failure cases. And 100% everything covered is in this area not possible. This is also to be said. What is, another question can be the requirements, how can the requirements quality be too high? I hope I never said this. Requirements quality can never be too high. It can be just brilliant, but cannot be too good. Well, probably a misunderstanding. Another one is, since fall injection test rests on requirements, and tests also rest on, or test also rests on requirements, so testing and requirements are interconnected heavily. The quality of the requirement statements be measured and matched to the quality of the test statement? Question mark. Yes, this is what's about. If you take your requirements and hold it against the testing, then you either improve your testing or you improve your requirements normally. That's what was the whole idea of this presentation, that both together give the solution. That's so far. There are more questions. Maybe I will have a look. Maybe Michael, there is a question for you there about Vectorcast. You can answer, and I think about the answers of the other questions there first.
Yeah, I think the first question I see here, hello, does Vectorcast C++ also support for injection in safety MCUs? For instance, TI TMS 570 ARM Cortex has a capability to inject fault via external hardware or via internal software. Thank you. To be honest, I think I don't understand the question. So what Vectorcast is doing, here is a dynamic software testing tool, really. So what I was doing here, I was injecting the faults through the software. I don't know if I answered the question, but I'm happy to take it offline and answer this through emails to get more details about this.
I think there is one more for you, isn't it? Can we add some code for fault injection requirements in Vectorcast?
Yes, and the demo you showed was mostly related to software level. It would be great to know more on system level if we get some more time. So yes, you can add software. You can add anything more for fault injection. I think sorry, I think I mixed two questions. Okay, the first one, can we add some code for fault injection requirement in Vectorcast? Yes, you can add. The second question, how to analyze the impact of the failure that is injected, and the demo was you showed was mostly related to software level. It would be great to know more on the system level if we get more time. So yes, so if you think about creating test cases with Vectorcast, we are all about functional and unit testing levels on the V model. In terms of system testing, yes, we can work on system test level also, though we would use whatever tool you are using, or whatever scripting mechanism you're using, or whatever methodology for system testing you are using. So we would adapt to this mechanism, but you would not create test cases in Vectorcast for system tests, because every project has a different methodology, every different tools, hardware, etc. There's another question. What is ASIL? I don't. That's I think for you, Martin. Question.
Yes, the ASIL is just criticality. All this in safety critical areas in all industries, we have different levels because not every system has the same criticality, and there are just 4 different levels in the automotive industry: ASIL A, B, C, and D, and the ASIL D is the highest critical level. So where people can die. Where in ASIL A only a minor impact can happen. Yeah, there is this whole topic in itself, but just give you a rough idea about it. And then another question was very interesting, what about SEU affect the code? Yes, actually, all the environmental testing, this is a debate and a philosophy maybe, how you look on it, yeah. But I excluded intentionally the environmental testing, let's say, so like electromagnetic influences or temperature, shock, vibrations, all this stuff. I didn't consider this because there you have normally your own test procedures and you have your completely different way of proving it, and it's very, very difficult. I am not sure whether it makes sense to take fault injection testing in the 26262, especially on the software level, to interpret it like that. I'm not sure, I don't know, maybe the people who wrote the standard have all of this in mind. I doubt it actually. From my point of view, this is a different topic. You have a defined area where the system shall work, and there you're going to test it. Yeah. Environmentally, yeah, from our environmental point of view. Yeah, I think the question is, okay, how to the next question, I think, how to introduce real hardware errors through SVD or JTAG or something similar. Let me give an answer from a method point of view. Real hardware failure, yeah, if you think about a RAM failure and your software source code, the RAM failure where your software source code is located and this is not working anymore, then it's pretty difficult, and there's Vectorcast just the wrong test level from my point of view to prove such things. And this is actually more proven by a concept, by, as I said, system architecture, as a system, hazard and risk analysis, and all what is following in out of that. You have a watchdog or whatever, how you ever discover failures when your software goes completely wrong. Failures, arbitrary failures that just a bit flips, yeah, and the software does get different values suddenly. That's what you can test on unit level. Yeah, you test your software independent of your hardware. You can write on a register in the real world on a hardware register. For software testing, you just map this register to an address, to a different address, but the mechanisms behind is all the same. So to quite an extent, you can test with Vectorcast or similar tools such scenarios. Yeah, you can test hardware failures, but of course not all of them. Yeah, there's no doubt. So from my point of view, we have answered the questions.
I have to say, yes, I have to say that our time is already gone. So I like to thank Martin and Mihao for the presentations. I thank all attendees for spending your time with us.